thinking through how our query is written, both inside and outside of the stored procedure. When we're writing the query with this join, and on the little ref.firstName table, we're saying where first name equals Matthew, SQL Server can, on that little ref.firstName table, it does have statistics available to it on that table. But think about what that table is. It's a 0.003 gig table where each first name has one row. So the statistics on first name describe Matthew has one row in this table. SQL Server knows that doesn't tell it how many rows Matthew has in the larger table. On the larger table, first name by birth date, 1966 to 2015, the one that's 3.7 gigs, we have statistics for the first name IDs. So SQL Server knows how many rows there are. It could use the histogram for a given first name ID, but it doesn't have the first name ID. We're joining on first name ID. The predicate is on first name. What is Matthew's first name ID? Well, SQL Server could figure it out, but to figure it out, it would have to actually query ref.firstName. It would have to actually do data access. And optimization has to happen really, really fast. SQL Server wants to give you an execution plan for that query and get you going ASAP, because if it started running queries to optimize a query, wow, that counts as part of your query's duration. And that's not how optimization works right now in SQL Server. So since it doesn't have the first name ID, if you don't have the first name ID, then I agree, your best bet is to say, okay, if I don't know what the first name ID was and I need to generate your best bet query, okay, well, let's look at if what's most likely the best number for any given first name ID. And using the density vector and multiplying it by the rows gives you exactly that. When I changed the query, essentially what I did was I ran a query ahead of time myself and looked up Matthew's first name ID. I did the data access for SQL Server, and then I put the first name ID in the query. Armed with this information, it said, oh, hey, okay, yeah, I've got a statistic on that first name ID. I can look at the histogram. I've got a great estimate for Matthew. We shouldn't do all those key lookups. It's faster to do a clustered index scan, and we also got that green index hint saying, okay, there could be an index that could make this better for us. So when we gave SQL Server more info, it was able to do a better job optimizing the query. It was able to use the histogram. And this piece of information about why it's slow and how providing the first name ID can make it faster will play into some of the possible solutions that we'll cover. Not every solution relies on this, but it always helps to understand where SQL Server slowed down. Now, a quick note about the future. There are some exciting new features in SQL Server 2017, including the first version of a feature with adaptive joins. And this feature is interesting. The 1.0 isn't going to cover our use case that I've talked about in this example, but it's just that first version. The idea behind the adaptive join feature is having in our execution plan some joins that, if it's not as fast as SQL Server thinks it is, on future executions, it might change and it might run differently. It might be able to adapt. Now, a couple things to notice. This is about not just that first execution. So if all your queries only run once, if you've got a lot of ad hoc queries, that feature might not be that helpful. And it may be a long time, and we can't be sure if it's going to cover our scenario, but it is really interesting and really cool that the optimization / execution process is getting more interesting and more complicated, and the way that the query is initially optimized isn't always going to be the whole story. So let's dig in and look at different ways we can tune this query, since we need to currently provide the adaptation for RT-SQL.